Hello friends, in today's video we are going to talk about a basic introduction to a very important welding process, which is arc welding, and also we are going to learn about the different types of arc weldings which exist. Myself, Dr. Gurraj Singh. Now before we talk about arc welding, it is very important for us to know what is an arc. Now mostly we say that an arc is like a spark. You have to close your eyes when you start welding, but that's just a layman's way of explaining what arc is. Basically, an arc is created whenever there's a huge difference in potential difference and when the current starts flowing through a circuit, but somehow there's an obstruction in its path and it has to make its way through that gap. Now that's when the arc is struck. So an electric potential difference must exist in between 2 points for an arc to form. So this is the first requirement for arc welding. Now this phenomena that I was talking about, where the electrons, they make their way through an insulated path, which is usually a gap of air. Now this phenomena is called as dielectric breakdown. And this dielectric breakdown, it occurs whenever there's an obstruction to the flow of electrons, but the potential difference is sufficiently high so as to break through that obstruction. So this happens when the physical forces, they attempt to balance out the difference between the charges. So a channel is created in which the heat and the high voltage, they ionize the gas between the poles to form an electrically conductive plasma. So this is the most important point that you need to know, that what actually happens when we are forming an arc, when an arc gets created, the gas in between that path, which is usually air, it gets ionized, and that is when it starts conducting current. So only current can flow through this plasma channel now, right? So only current is going to flow through this plasma, and depending upon the type of power source, the breakdown can occur as a spark or a flash and is extinguished just as rapidly as the difference in charge is balanced out. So to explain this in a better way, let me just draw a small circuit here. That, there's a power source somewhere around here, and this is the circuit. Now you take this as the positive terminal, this as the negative terminal. Now obviously the electrons, they are going to start flowing in this direction from the negative to the positive terminal. Now if there's a small obstruction to the flow of electrons here, so what will happen? The electrons will not be able to go further beyond this point, because air is basically an insulator. It's not a medium through which electrons can easily move. But if this potential difference, the potential difference of this power source is sufficiently high enough, it can empower these electrons to break through this air gap. What is it going to do? It is going to ionize the air molecules which are existing in this gap. So basically it will ionize them into positive and negative charges. And then the electrons will make their path and move through. And that is why we were saying that only current can flow through this channel. But for that, this dielectric breakdown must occur. And for that, you need to have a sufficiently high potential difference. So this is how the arc is created. Now that spark that you see is basically the magnificent energy that is released, because the kinetic energy of these electrons gets converted into heat energy. Why? Because the ionization potential of air, it gets surpassed, the dielectric breakdown occurs, and that's basically the energy that is released, and you can see it in all of these images in different forms. So this is the energy that is being released when the electrons are trying to pass through that air gap. Now if we define arc welding, now we have all seen this process. some time or the other in our life, we have seen this process where the welder is covering his face with a mask and he's trying to prevent his eyes from getting damaged that is being produced. So this is what we see, and this is what actually occurs. Near the welding zone, this is what is actually occurring. Now, obviously, this is this particular image where the metal is getting transferred from the electrode to the weld pool that you see at the bottom. Now, this is a case for the welding processes which have consumable electrodes. And yes, there are processes with non-consumable electrodes as well. So we will see that as we progress through the welding lectures in the coming videos. But for now, this is one type of transfer that is taking place during arc welding. But we'll again come back to the main topic, that what is arc welding? So arc welding is a process where electric arc is used to create heat to melt and join the metals. So in any welding process, we need heat. Heat is the main source of welding, because if you have heat, you can melt, and you need the metal to melt down if you want to weld it. So in case of arc welding, you use an electric arc to create that heat to join those metals, be it similar metals, be it dissimilar metals. And yes, one more thing, this heat needs to be accompanied by pressure. So in most of the cases, you will require to exert a certain amount of pressure in combination with that heat to accomplish your weld. Now the power source, it creates an electric arc between a consumable or a non-consumable electrode. So again, I've re-mentioned this, and we will be talking about this in the future classes. And the base material using either DC or AC currents. So therefore, the heat source, it can be either direct current or it can be alternating current. An electric arc from an AC or a DC supply, it creates intense heat of around 6500 Fahrenheit. So it's a very, very high temperature, and it is sufficiently high to melt most of the metals. So this is how the welding takes place, and you can just pay attention to this small image here. So you see the welder, he is holding the electrode in his hand, and then there's the work pieces. This is the one, this is two. So both of these are being joined, and this is the weld or the weldment that has been formed. Then you have this working cable which is connected to the welding machine. So this welding machine, it has a certain polarity. Maybe this is positive and this is negative, or the other way around. This can be negative and this can be positive. So again, this is the case of polarity. So polarity, we'll discuss it in a full lecture. So this is how the welding takes place. Now if you want to classify the different arc welding processes, there are many processes, but these are the 6 most well-known and most commonly used processes. And among these, the top 3 are very common. All of you must have seen this. So the first one is shielded metal arc welding. So we usually write it as SMAW. Then we have tungsten inert gas welding, which is commonly known as TIG welding, but we can also call it as gas tungsten arc welding. So therefore we can refer to it as GTAW as well. Then we have metal inert gas welding. So that is referred to usually as MIG welding. Then it can also be referred to as metal active gas welding. Now I've replaced inert gas with active gas. Now these gases, as we learn in the coming classes, they're used for shielding the weld pool. They're used for protecting the weld pool from atmospheric contamination. And mostly we are making use of inert gases, like we can say helium, we can say argon, but in some cases we can use active gases like CO2. So we can use carbon dioxide as a shielding gas. So in that case, your MIG welding will be referred to as MAG welding. And then we also call it as gas metal arc welding, like we called the previous technique as gas tungsten arc welding. You just replace the tungsten with metal. Why? Because the electrode in that case is always made up of tungsten, but in this case it can be any metal depending upon the metals that are being welded. So MIG, MAG or GMAW. Then we have a submerged arc welding process, SAW. Now that is a process where the arc is usually submerged. You don't see the arc. It is submerged under a pile of flux. So we'll have a full lecture dedicated to this process in the coming classes. Then we have two more processes, electro-slag welding and then a plasma arc welding process. And I would like to mention that out of these, the plasma arc welding process and the tungsten inert gas welding process, these two processes have non-consumable electrodes. So these two processes, PIG and PAW, they have non-consumable electrodes. Rest all the four, they have consumable electrodes. We would be seeing this in the coming classes. For now, this was a basic introduction to arc welding. And please refer to the future videos where we will be discussing each of these techniques in proper details. Thank you.